Alright, hey guys, this is Wendy Ponomarenko with the San Diego Science and Education channel. I wanted to highlight some things that have happened recently and that are coming up a little bit. Today is Family Activity Day, so I have some Pi Day activities ready for the family to do, ready for anybody to do, so that they could have some wonderful math experiences with their family with Pi Day coming up. Here's a good way to show your kids and your family how important math is. Here we go, though. Just yesterday, I spent some time over at the first robotics competition. One of my children was in it, and I want to say it was very cool. If anybody has a chance of encouraging one of their children to get into a robotics club or a robotics competition, the kids seem to have a great time. And if you're interested in robotics, they can always use help at the first robotics competition. So definitely, I'm going to be including some links and some information for that, so make sure you check it out. We had a great time. Now, moving on, this Wednesday is Pi Day. That is 3.14 March 14th. So in honor of this wonderful day coming up, I wanted to bring in some different activities that you can do with your kids, math-based activities for Pi Day. Here we go. Now, on the board behind me, I've created six circles that are cut into different pieces. These are just warm-ups. Most of the activities actually that we're going to be using are actually from NASA. The NASA website actually has a Pi Day challenge that they have done every year for the last 4 years. This is the 5th year they're doing it. And it's based on real problems that they've actually had to use pi to solve in real-life space-oriented situations. And they've got it set up in ways that grades about 6 to high school, 6 to 12, can actually actively participate in and actually do some of these. And every year they put up these challenges, and then the day after Pi Day, March 15th, they put up the answers. So you can actually challenge yourself, challenge your family, get some work together, and then you get your chance to actually see how well you did the next day. So make sure you check that out. So first we're going to do a warm-up. I have a couple of volunteers. Volunteer. Here we have Jeff.
And Felix.
Felix. So Felix.
Introduce ourselves.
All right. So we're going to do some Pi Day activities. These are my wonderful Pi Day volunteers. And here we go. So our first pi right here. First, how many degrees are in a circle, guys?
360.
360. That's right. Good job. So there's 360 degrees in a pi. This does not actually in a circle. This does not actually use pi for the formula, but it's a good warm-up. It's basic division. So here we go, guys. The first pi we have is cut into 4 pieces.
90 degrees.
Okay, that's 90 degrees. You could wait till I finish the question.
Excellent.
Okay.
Yeah.
Okay. The next pi is cut into 3 equal pieces. What are the degrees of each piece?
120, because isn't 12 times 360? 36?
Yes.
And
so 360 divided by 3 is 120. Good job. This is my 4th grader. All right. This is my 7th grader. Okay. So this pie right here is cut into 5 pieces. What are the degrees if you cut a pie into 5 equal pieces of each piece? Think about it. 360 divided by 5.
75?
Not 75.
72.
72. There's someone who remembers. 72. You were right. 72. You were right. 72. Good job. Okay, now this one's really easy. This pie, guys, this pie has been cut into 6 pieces. What are the degrees of each piece?
Might it be 60?
It might be 60. It's a little easy.
6 times 6 is 36 plus 0.
So, yes, 360 divided by 6 is 60. There you go. Good job, guys. So this next pie is cut into 8 pieces. This is actually one of the more difficult ones. So right here, 8 pieces.
Isn't that just half of one of those pieces?
It is half of the 90 degree
So shouldn't
pieces.
it be 45 degrees?
Yes, half of 90 is 45. So each of these pieces would be 45. That is exactly right.
sorry,
Good
what?
job. Okay, and for the last pie we're looking at, in this particular case, The day one, my Y one, my last one. This is cut into 9 equal pieces. If you cut a pie into 9 equal pieces, which is a little difficult, but we can manage it, what are the degrees of each piece?
Not 42.5.
Not 42.5, no. 360 divided by 9. If you think
Oh, 40.
40, that's right, good job, because 36 divided by 9 is 4, so 360 divided by 9 would be 40.
That's what I was thinking.
Okay, so now we've got some circumference and some area, so we're actually going to be using pi. Here we go, guys. Are you ready? This pi has a radius of 2. So the circumference, the formula for that is 2 pi r. So that's 2 times pi, which is 3.14. The radius is the distance from the center of the pi to the edge.
Okay, 6.18, 6.28 is 12.36.
Not 3.6. Because 28 times 2.
12.56.
12.56. There we go. Okay, guys. Now we're using a workspace right here. In this case, it's the floor of our house. And I've discussed with the boys some of the different NASA problems that are on the NASA website this year for Pie in the Sky 5, which is the Pi Day challenges that they've set up for this year. Let me tell you about some of the different ones that they have up for this year. Okay, the first one, can I borrow yours? Okay, the first one is actually the solar sleuth, which is talking about exoplanets and how to find exoplanets because they transit in front of their star, and they actually cause that star to dim a little bit, and you can actually measure how much the star has been dimmed based on that whatever planet has crossed in front of it, and from that you can figure out the size of the planet. Jeff has decided to work on this one. Which is the solar sleuth. And then Felix has decided to work on the next problem, which is the helium heist, which is talking about Jupiter. Yay! Go Felix. With a radius of 70,000, Jupiter is our solar system's most massive planet. About 10% of the volume from Jupiter's cloud tops is 20,000 kilometers below its helium, with the rest being mostly hydrogen. Circulation in this molecular hydrogen layer causes some of that helium to be depleted as it moves into the liquid metallic hydrogen layer beneath. The tremendous pressure inside Jupiter condenses helium into droplets that fall like rain through the less dense liquid metallic hydrogen. It rains helium on Jupiter. How cool is that? The presence of helium rain inside Jupiter helps explain why scientists observe less helium in the clouds than expected. If 10% of the helium volume in Jupiter's molecular hydrogen layer has been rained out since the planet formed, what is the volume in cubic kilometers that has rained out? Not bad. That's a pretty cool problem. So these are the 2 problems we're going to be working on. Interesting and awesome problems. All of them are ones that NASA actually had to use pi to solve during this year. So these are all real-life problems that were all used with pi. So here we go. Now we're going to work through this. Hello. I would suggest that if you have a dog, you might want to do this work on a table instead of on the floor. Hi. Okay, so Felix. Okay, back to this. Here we go. So Felix plugged in the 70,000 kilometers radius of Jupiter and the 50,000 kilometers of the inner radius, and then found the volume of Jupiter as a whole, and then the volume of the smaller part, and then subtracted that part out, and got, I didn't mean to poke you, and then got about 913 trillion 156 billion kilometers cubed. So there we go. And for the other part, so given the data from the Earth, here we go. Given that the Earth's radius is 6,371 kilometers, how many Earth-sized spheres of helium have been rained out? So then we figured out that part and got Okay, so 91,315,600,000,000.
Whoa. 91,315,600,000,000
Kilometers cubed. Very good.
We finished!
We finished. So that was some pretty good work, kiddo. Dab. Dab. Okay. All right, and now for Jeff. Jeff had the exoplanet problem. So how did you work through yours?
Well, I solved it by what I first figured out was
Here,
that
exoplanet right here.
I needed to multiply the ratio or the percent drop in brightness by the disk area of the sun. That way I could find the area of the planet. So I did that. I got 174,720,000, and then I realized that it asked for the radius, not the area. So then I figured out that the area to find the radius, I needed to find the square root of a over pi, and so I did that, and I got 7,457.55 blah blah blah.
Okay.
And that's what I got.
All right. Well, very good. You were supposed to find the radius of the exoplanet, known as Kepler 186f, and what you found was the radius was 7,457.55 kilometers squared. Very good. All right. So there we go. These are some challenging and yet family-friendly activities on real-life problems using Pi as an activity for Pi Day. If this is too advanced for your family, the warm-up ones are a perfectly good one, and there's a lot of those you can come up with, giving kids just basic circumference, finding the area, finding the degrees of a pie piece before you serve them a piece of pie on Pi Day. There's all kinds of wonderful things you can do. Enjoy Pi Day, have some wonderful math activities, and have a wonderful day.